motion. So if you are in physics or have been in physics, then projectile motion is most likely, shouldn't be something that's brand new to you, but we might be looking at it a little bit different. So parametric equations, which is what we're talking about right now, are often used to model projectile motion. If an object is projected at an angle of elevation of theta, to the horizontal distance and vertical position of the object can be represented by the following parametric equations. Okay, so this is what it would look like. X equals t times the initial velocity times the cosine of theta. Okay, so t is time in these particular cases. That v sub 0, that is the initial velocity. When we talk about vertical position, we'll not only use time and initial velocity, but we'll also use the gravitational constant and the initial height. So that's what the other variables are there. So the vertical position looks like this. Y equals t times the initial velocity times the sine of theta. So far these look the same, but this has sine instead of cosine, but this one keeps going. Minus 1/2 times the gravitational constant times t squared plus the initial height, h sub 0. So that gravitational constant, it is a constant, even though we're using a variable, but it changes depending on what units you're using. So it's the acceleration of the object due to gravity. At the surface of the Earth, the value is 9.8 meters per second squared, if you're in meters, or 32 feet per second squared if you are in feet. So that means that, I'll just write them out over here. We've got 9.8 meters per second squared, or 32 feet per second squared. Okay, so acceleration has the second squared on it. All right, so let's read this first example and see what all kind of information we can get out of the question here. So it says, Mark kicks his soccer ball upward from the ground. So from the ground tells me that the initial height is 0, because it's at the ground, with an initial velocity of 75 feet per second. So my initial velocity, 75 feet per second. And an angle of elevation of 62 degrees, theta is 62 degrees. The other thing that I can get from this right now is the gravitational constant, because again, it is a constant. I just have to know my units, and we're talking about feet here, so my gravitational constant is going to be 32 feet per second squared. Okay. Everybody good with all that and where all that came from? All right. So I'm going to make a diagram of the situation. So here's my x and y. And since these are parametric equations, that means that it's actually the path of what's happening. So it's coming from the ground, going to kick the ball, comes up off the ground, and then eventually it's going to come back down. And that angle of elevation right there is 62 degrees. So there's my little diagram. Then I'm going to need to write the equations. And it's telling me to write an equation. I'm not solving for anything in B. I'm using these two things here to write my equations for the horizontal and vertical position. So my horizontal position, that would be x equals t, which I don't know, times the initial velocity, which is 75, times the cosine of theta, which is 62 degrees. There's that one. Then y equals t times the initial velocity, which is 75, times the sine of theta, so that's the sine of 62, minus 1/2 times g, which is 32, times t squared, plus the initial height, which is 0. So I got all that from those up there, and then I'm just going to clean this up. That means that y equals t times 75, no, not times 75, times 62, sorry. 75 times the sine of 62, minus half of 32 is 16, t squared, and I don't have to worry about the 0, There's that one. Okay. Any questions about my equations there? Okay, so then we are going to find the horizontal distance when the ball has traveled at 2 seconds. So t equals 2. And I have my equation for that. That's this one. The x is the horizontal. So that means that x equals 2 times 75 times the cosine of 62.
Yes, how did you get g equals 32?
Right here. Gravitational constant. It's 32 feet per second squared. Okay. All right. So then you just type this in your calculator. So I make sure you're in degrees. So I'm going to get 2 times 75 times the cosine of 62. So then I get 70.421. That's my answer. And that is in, since this is a horizontal distance and I'm talking feet, this is feet. Don't forget your units on things. There you go. Okay, we all good with that? All right, so then it says find the vertical position when t equals 2 seconds. So now I'm just substituting it into this one. So this would be y equals 2 times 75 times the sine of 62 minus 16 times 2 squared. I'm just going to substitute that in. So I'm going to get 2 times 75 times the sine of 62. Ooh, I don't need 2 of those. Then, what am I doing? Minus 16 times 2 squared. Bam. There's my vertical distance. Okay, so make sure you're getting those numbers. So we get y equals 68.442 feet. Ooh. What questions do we have? Okie dokie. So then I want you to read this, and I want you to come up with the initial height, the initial velocity, theta, and g. So read through that, come up with those pieces. Not necessarily in that order, I just... Okay, so as I read through this, it says a tennis player serves a ball at an initial velocity of 35 meters per second. So my initial velocity is 35 meters per second. The ball leaves the racket at a height of 2 meters. So my initial height is 2 meters. Angle of elevation is 45 degrees. Since this is all in meters, my gravitational constant is 9.8 meters per second squared. Do y'all agree with all that? Okay. So then it says to make a diagram of the situation. All right, well, see what's happening here. Serving a ball, initial velocity. So serving a ball, and it doesn't start from the ground. It starts from like 2 meters, right? So when she serves the ball, it starts here. It's going to go up, and then it's going to come back down. Or maybe somebody hits it. We don't know what's happening over there. But the angle here is 45 degrees. There's your diagram. Okay. So we write the parametric equations. All right, well, x equals time times the initial velocity, which is 35, times the cosine of the angle, which is 45. That's my x equation. Then I have to come up with y. Y is equal to t times the initial velocity times the sine of 45 minus 1/2 times the gravitational constant, which is 9.8, times t squared plus 2. So all I really need to do to clean that up is to just take half of that 9.8. So y equals t times 35 times the sine of 45 minus 4.9 t squared plus 2. So there is my y equation. Any questions about those two? All right, so then just like the one above it, C asks for the horizontal distance and D asks for the vertical position. So I'm going to use these two equations to come up with these answers. So you go ahead and do that. Write it down, substitute it in, come up with your answers. Give you just a minute to do that. So those are the two numbers I got. Do you agree with me? Do we have any questions? Yes, sir. I literally type it exactly like this. Anything else? Do you have a question? Yes, but I can let you go to the restroom if you need to go. Okay. Okay. Here you go. You're welcome. All right. Let's look at number 3. Because yes, it is different. But at the top, I'm going to write what my generic equations were again. So they were x equals t times v sub 0 times the cosine of theta, and y equals t times v sub 0 times the sine of theta, minus 1/2 times g times t squared plus h sub 0. Okay, so those were just the formulas we had at the beginning. So let's read through this and come up with what we know. Football is kicked from the ground. From the ground means initial height is 0. 45-degree angle of elevation, theta, is 45 degrees. Initial velocity, 60 feet per second. Initial velocity, 60 feet per second. How long is the ball in the air? So the other thing that we don't have on here yet is that gravitational constant. So gravitational constant here, since we are in feet, is going to be 32 feet per second squared. Okay. So it's asking me, how long is it in the air? Well, we're kicking it from the ground. Now, it didn't tell us to draw, a diagram, but sometimes those diagrams help to make you think about what's happening. So I'm going to kick this up in the air. Eventually, it comes back down. Whether or not it looks like an exact parabola, it doesn't really matter. But it's going to look like this, right? So it's on the ground 2 times. It's on the ground here, and it's on the ground here. Make sense? Because our height is 0 both times. That is the x, those are the x-intercepts, those are the solutions, those are the roots, those are the things that we always look for with quadratics. So if I'm going to have a quadratic and I'm going to have a parabola, then it's this is my whole thing here. Why? This is that vertical distance that we're talking about, like this. So I'm going to set up that equation. So y equals t, which I don't know, times the initial velocity, which is 60, times the sine of 45, minus, so 1/2 of g, I'm just going to go ahead and put in 16 t squared. And then h sub 0 is 0, so I'm not even going to put plus 0. Okay, so there's the equation for my parabola when it's time and height. And if I want to know how long it's in the air, I have to find the zeros, right? I have to find these 2 spots. Even though I don't care about this one, I want this one. So I do that when that's true when y equals 0. So I set it equal to 0. It's a quadratic. How do we solve quadratics? What's the first thing we usually try? Factoring. Can I factor this at all? Yeah. Do you have a GCF? Yep, that's always the first thing you look for. I got a GCF, so I'm going to factor out that t. That leaves me with 60 times the sine of 45 minus 16t, and all that equals 0. Solving quadratics, because we should be experts at this. So now that it's factored, I set each factor equal to 0, just like we've done 5 million times. So when I take this t, I get t equals 0. That's my first answer, which is not the answer that I want. It's this one. I already knew that, right? It's on the ground when it starts. I already knew that. Not a big shock. But now I have to do the other one. So then I'm going to do 60 times the sine of 45 minus 16t equals 0. So then that's going to give me 60 times the sine of 45 equals 16t. Divide both sides by 16, and I will get that t equals 60 times the sine of 45 over 16. Okay, everybody okay with that? So then I'm going to go to my calculator. And I'm going to make a fraction. And that's going to give me 60 times the sine of 45 in the numerator. And in the denominator, I have 16. And then I'm going to make sure I don't hit clear after that because I'm going to need this answer. You don't always know if you need them or not, like to move on. So I'm telling you right now you're going to, but you don't always want, you want to not hit clear until you know you don't need it. So there's my answer. It says, how long was it in the air? Well, that's your t answer. So that is t equals 2.652 seconds. Because the height is 0 at 2 different times, here and here. But that doesn't make any sense. It was in the air 2.652 seconds. Okay, we good? Any questions? All right, so then it says to find the total horizontal distance the ball traveled. So the total distance is going to happen in 2.652 seconds. Horizontal, this is horizontal. So I'm going to get x equals t times my initial velocity, which is 60, times the cosine of the angle, which is 45. And I wrote t instead of the 2.652 because I'm not typing that back in. This I'm going to get from here. So in my calculator, I'm going to take the answer times, and what was it? 60 times the cosine of 45. And that is my answer, 112.5. And it's not 112.500 because the calculator gave me exactly 112.5 with all my weird, crazy numbers. So if that's what it gives you, that's the answer, and that is in feet. Okay. What questions do you have? Anything? We good? Okie dokie. All right. So a baseball player in the outfield throws a ball towards home plate. The ball leaves his hand at a height of 6.5 feet. Initial height, 6.5 feet. Initial velocity, 110 feet per second. Gravitational constant, 32 feet per second squared. That's all I'm getting from that one right now. So then it says, the ball is caught by a player at home plate after 1.8 seconds. T equals 1.8. If the ball traveled a horizontal distance of 191, that means the horizontal distance is x, that's 191. Find the angle of elevation. Theta is what we're looking for. Okay? So they give me the horizontal distance and want me to find theta, so I'm going to have to use my x equation. So that would be x equals, I'm just going to write down the generic one, t times v sub 0 times the cosine of theta. Then we're going to plug in everything we know. I know x, it's 191. That's equal to t, which is 1.8, times v sub 0, which is 110, times the cosine of theta, which we don't know. Okay. Now, you could multiply 1.8 times 110, but I'm not going to. I'm going to let the calculator do it all at once for me. If I'm trying to get theta by itself, I'm going to divide by both of these. So I'm going to get 191 divided by 1.8 times 110. That's equal to the cosine of theta. That means then that theta is the cosine inverse of 191 divided by 1.8 times 110. Then I'll let the calculator just do it all at once. But depending on which calculator you're using, you may have to put that whole denominator in parentheses. If you can't make it into a fraction, it needs to be in parentheses, so be careful with that. So over here, I'm on a new question, so I'm going to clear off the old stuff. And I'm going to find the cosine inverse of, and I want this to be a fraction, of 191 over 1.8 times 110. If you'd rather just go ahead and multiply that out and figure out what it is, that's fine, but not necessary. And there's your answer, 15.281. So your theta is 15.281 degrees. Then it goes on to ask, what was the height of the ball when it was caught by the player at home plate? So I know when it was caught at 1.8 seconds, right? I know that much, so I can write out my equation. So y is what I'm looking for. That's equal to the time, which is 1.8, times the initial velocity, which is 110, times the sine of theta. I'm just going to write theta because I'm actually going to use the number that's in my calculator, minus half of the gravitational constant, so that would be 16, times 1.8 squared, plus the initial height, which is 6.5. Okay, so then at this point, I'm just going to type all that into my calculator. And remember, I'm not typing this number in, I'm using what's in my calculator. So I'm going to type in 1.8 times 110 times the sine of the answer, right there, I'm going to close my parentheses, minus 16 times 1.8 squared plus 6.5. Literally just type it in exactly like it's on your paper. You get 6.842. So y equals 6.482. This would be feet. Okay. What questions do we have? Anything? We're all good? Okay. You have a question? It's 842, and thank you. And I think that's what I don't know if that's what I said or not. No, thank you for asking me, because then I wrote, okay, so I said the right thing. Okay. I don't know why my brain and my hand don't always agree. Like, I don't know what's going on with me. I'm sorry. But thank you for catching that. It is 842, yeah. Because then I'm like, I don't even know what I said at that point. But that's the correct number. So good. Thank you. Anything else? All right. Let's look at example 5. So we've got a projectile is fired from the top of a 24-meter tall building. So our initial height is 24 meters. Angle of elevation, 28 degrees. Theta is 28 degrees. Initial speed, 55 meters per second. So my initial velocity, 55 meters per second. And that makes my gravitational constant 9.8 meters per second squared. All right, so my maximum vertical height reached by the projectile. So do you remember when you were dealing with quadratics, how you found the maximum height? Does negative b over 2a make sense? So my maximum time, so the time at which it is the maximum height, so your max height time, I guess, is max height time is negative b over 2a. That is definitely something that you did in Algebra 2. In order to come up with that, I have to have this in quadratic form so that I can get my b's and my a's and all that good kind of stuff. So that I'm going to have to come up with my y equation here. So y is equal to the t that we don't know times the initial velocity, which is 55, times the sine of theta, which is 28, minus half of 9.8, which is 4.9, times t squared plus 24. Okay. So for a quadratic, you have ax squared plus bx plus c. That's not what order this is in, but that's okay. I know from this that a would have to be negative 4.9. The b would have to be 55 times the sine of 28. And c would have to be 24. That's your a, b, and c. They're just not in the right order. Okay? A is always with the x squared and whatnot. So when I want to find the time when it's the maximum, so t would equal negative b over 2a. So that's going to be negative 55 times the sine of 28 over 2 times this, which is you're back at 9.8, so negative 9.8. So we're going to put that into our calculator. I've got, what am I doing here? Negative 55. Oh, hang on, I wanted a fraction. So I'm going to have negative 55 times the sine of 28 in the numerator. In the denominator, I have negative 9.8. That gives me the time at which it hits its maximum height. 2.635. So this is 2.635 seconds. Not my answer, because it didn't ask me when. It said, what is the maximum vertical height? So now I have to take this, and I substitute it in for t here and there. So I'm going to go back over here, and I'm going to type that in. I'm going to have the time, which is my answer above, times 55 times the sine of 28, close my parentheses, minus 4.9 times t squared, so that's the answer squared, plus 24. And I'm not even going to hit enter. I'll tell you why here in just a second. You can, but I'm not going to, because it still gives me my answer just fine. So my answer is 58.016 meters. That is the maximum height. This is the time at which it reaches it. That is the maximum height. So then it says to find the horizontal distance traveled by the projectile at the time it reached the maximum height. So this is when it reached the maximum height. And my equation looks like this. X equals t times the initial velocity, which is 55, times the cosine of the angle, which is 28. So I need to use that answer again. So remember how we copied and pasted the other day? If you hit enter, you could go back and copy and paste this so you get it exact. But if I want this to still be the last answer, I can just back out of this. And then I can start over and say the time, which was my answer, times 55 times the cosine of 28. That way I was able to still use that answer up there. And I know I'm using the right one because it's showing me. And I get a different answer than what I have written. Is that what y'all got? Okay. Okay, we did it right. It's just not what I have written down. Sometimes that's, I have no clue where I got the number I have written down. All right, so then we end up with 127.951. And that's meters. No, that's okay. I have this number written down, and I have this number written down, but when I use this in the correct... Okay, hang on, because I didn't do it. Did I do something wrong? I didn't. That's my initial velocity. That's my angle. Okay, I just have the wrong number written down, I guess. Okay. $61 instead of 51? Oh, shoot, did I write down the wrong number again? Y'all, what the heck? No, 951. If you got the wrong, if that's wrong, then did you use the whole answer? Did you type any digits in for this? Then that's why you're wrong. That's why you can't do that. Okay, so now that I'm going to go back and look at that again just to make sure. I'm sure this is wrong, but all right. So if the projectile is fired towards a taller building that is 300 meters away. So if the projectile is fired toward a taller building that is 300 meters away, will the projectile hit the building? If not, how far from the building will it land? All right, so let's think about what that means. We are firing from here, so we have this building. We have a taller building, right? And that taller building, let's say it's 300 meters away. So this is 300 meters. When we fire this projectile, it's either going to hit the building or it's not going to hit the building, right? And if it doesn't hit the building, I got to figure out how far away it is. So let's find so we'll eventually have to find the horizontal distance, but we need to set up our y equation first because it's fired up here. So our y equation for this is t equals 55, not equals, oh my Lord, have mercy, sorry. T times 55 times the sine of 28 minus 4.9 t squared plus 24. So here's what I need to know. I need to know when this would hit so basically, is it going to hit the ground within that 300 meters? So I need to know, once I launch it off of here, when would it actually hit the ground? That's what I need to know. So when t is 0, I need to solve for t. In this case, I can't factor this. If I need to solve for t, here's where we use the quadratic formula. Maybe you're still singing it in your head, right? x equals, well, this is t, negative b, this is my b, so negative b, 55 times the sine of 28. I'm doing this because I can't factor this one. I can factor the other one. Negative b plus or minus the square root of b squared. So that's 55 times the sine of 28 squared minus 4 times a, which is negative 4.9, c times 24. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? This is why I don't teach choir either. 2 times negative 4.9. Sorry that I just subjected y'all to that. This is going to give me two different answers. That's why I have a plus or minus, right? So when I do that, I'm going to be smart about this in my calculator too. So I'm going to go to my calculator. I'm going to clear off everything I have. And I want it to start as a fraction because it's a big old fraction. So I'm going to have my negative b. So that's negative 55 times the sine of 28. Close my parentheses. Then I have plus or minus. I'm going to start with the minus. Then I'm going to have a big old square root. In there, I'm going to have 55 times the sine of 28. Close both of those parentheses so I can square it. And then it's going to be minus 4. I don't know why this one go away. There you go. Minus 4 times a, which is negative 4.9, times c, which is 24, all over 2a. So that's 2 times a negative 4.9. So I got 6.0, I did hit enter. I didn't hit enter. 6.0757. So let's go back over here. So I got t equals, so I have two answers, 6.076 seconds. Now I need the plus one, right? So I'm going to go back over here. All I have to do is change this. Take that, I'm going to back that out, change that to plus, and I get a negative answer. So that's negative time. Is that going to make sense for me right here? No. So I actually need the other one. So I'm going to back it out again and put the negative back. That's the one I actually want, right? Then I'm going to hit enter so that I have it. So the other one was t equals negative 0.086, I think. But that's not what I want. This is clearly the one I want. So I need to see how far that is when it hits the ground. Because if it's farther than 300 meters, then it'll hit the building. If it's less than 300 meters, then it won't hit the building. So my horizontal was x equals t times 55 times the cosine of 28. That's how I find the horizontal distance. But I'm using t from my calculator. I am not typing answers back, decimals back in, or I will get the wrong answer. So this is going to be t. This is my t, my answer. Okay, so I've got that times, I've lost my place here, times 55 times the cosine of 28, right? Yeah, 28. So that is 295.050. So what I get here is that x equals 295.0, 95.0 whatever, it doesn't even matter. Is it going to hit the building? No, because it hits the ground before it. And so it says, is it? And if not, how far from the building will it land? What do I actually need to do with this number? Subtract it from what? 300. So now I go back over here and I do 300 minus my answer, and boom, there we go. So it's 4.950. So the answer is no. It will land 4.950 meters away. So bringing back lots of that Algebra 2 knowledge that you need to make sure that you can have and handle with these equations. Okay. What questions do you have? Anything at all? All right, good deal.